Hello, my name is Carlos Alonso Ramos. I'm the coordinator of the SYMPHONY project. In this research project, we aim to fill a technological gap, which is the lack of a technology providing analysis of gas concentration and presence in the atmosphere with a device, with an approach that is compact, robust, low cost, and easy to use. So to address this challenge, we choose to make a combination between silicon photonics and AI. Silicon photonics mainly because it provides the capability to make large volume production of compact and low cost devices, and AI because it's a very powerful tool to improve the performance of our devices, allowing smart analysis of the gas that we are analyzing.
Spectroscopy is a powerful technique to figure out what chemicals we have in an unknown sample. It is based on the insight that white light, for example, sunlight, is a combination of multiple colors, and that different chemicals absorb different colors. For example, carbon dioxide absorbs certain wavelengths in the mid-infrared region very strongly. And by looking at which colors are missing from this white light, we can know which chemicals the light has passed through. Thus, we call the method optical absorption spectroscopy.
So, in SYMPHONY project, we focus on the detection of carbon dioxide and methane, both gases that have their absorption spectrum within the mid-infrared range. In order to fully exploit the silicon platform, we need to get rid of the silica underlayer. This is because this absorbs after 3.2 micrometers. One way of doing this is to use suspended structures like the ones showing here. These structures are based in a subwavelength grating cladding, which allow us to confine and guide the light.
A key technology behind these suspended waveguides is a wavelength grating technology. This technology allows us to guide the light into the chip by using a periodic arrangement of segments and gaps. However, these features are so small that light cannot resolve them, and instead of seeing them individually, the light sees an effective material. This effective material has optical properties based on the geometry of this periodic pattern. For example, based on the width of the segments, the length, or the periodicity. Every integrated circuit is made of a set of basic components or building blocks that perform basic operations. These operations are, for example, dividing the light into different branches using power splitters, combine it again using combiners, making it go slower, or make it interfere after that by using interferometers, or even deconfine it. How well these operations are performed and how well these building blocks are designed has a very strong impact on the performance of the final application and the final system.
So in multi-gas scenarios, we have different gases that may have similar absorption features, and this can be challenging for gas detection. For this reason, when we use AI models, we can reduce the effects of this phenomena, leading to more stable and robust gas detection. In order to train our deep learning models, we use scientific databases such as Hydran in order to simulate realistic and challenging environmental conditions.
Hello, I'm Thomas Dory, the CEO of BERT Energy. We have been building biogas plants for the last 16 years, and we are interested in SYMPHONY in the two applications, which is process optimization, which is important for us to get the maximum methane out of the plant, and also the leak detection, because leak detection is not only a pollution, but it's also a loss in profitability of the plants. Therefore, we are very happy to be part of this program.
Hope you have a great introduction to the SYMPHONY project.
Symphony runs until 2027, and all updates will be on the website.
So please free to stay tuned. Also follow us in the different conference and papers we have coming.
You can join to our LinkedIn group using the QR on the screen.